1.1 Atoms and Molecules. Learning Outcomes. 1.1b Interpret mass spectrum. C. Calculate the average atomic mass of an element given the relative abundances of isotopes or a mass spectrum. D. Calculate relative atomic mass based on carbon 12. Do you ever curious? How do we exactly obtain all these isotopes of an element in reality? How does the atomic mass value from the periodic table was obtained, and how do we know which isotopes of elements is the most abundant on Earth? By finish this lesson, I do hope that you are able to find out the answer of these questions. Isotope. Isotope can define as atoms of the same element that have different numbers of neutrons but the same number of proton and electron. For example, boron 10 with proton number of 5, number of neutron of 5 and the neutron number of 10, and boron 11 with the proton number of 5, number of neutron of 6 and neutron number of 11. Both of these are isotopes of boron, where they have the same proton number of 5 but different number of neutrons. The atomic masses of naturally occurring isotopes of an element determine the atomic mass of the elements. For example, chlorine Cl has two stable isotopes, that is 35 Cl and 37 Cl. The atomic mass of chlorine Cl is 35.45, which is determined by the atomic mass of 35 Cl and 37 Cl. The types of isotopes with its relative abundances can be detected by using mass spectrometer. This diagram shows the device of mass spectrometer. Sample is placed into the vaporization chamber, ionized and diffracted by the magnetic chamber according to its mass over charge. Ion beam is detected by ion detector and finally recorded as the mass spectrum based on its mass over charge and relative abundances. Given the mass spectrum of magnesium, y-axis we have relative abundance and x-axis we have mass over charge in the unit of AMU. Based on the spectrum, we can see that they have three lines showing in the spectrum indicate that magnesium consists of three isotopes, that is 24 Mg, 25 Mg and 26 Mg. The height of each line is proportional to the abundance of each isotope. So based on the mass spectrum, we can interpret that relative abundance for 24 Mg is 63. Relative abundance for 25 Mg is 8.1 and the relative abundance for 26 Mg is 9.1. Since 24 Mg is the highest peak, means 24 Mg is the most abundant of the three isotopes. Example, the mass spectrum of copper. Based on the spectrum, we can see there are two lines showing in the spectrum indicate that copper consists of two isotopes, that is 63 Cu and 65 Cu. The height of each line is proportional to the abundance of each isotope, so we can interpret that the relative abundance for 63 Cu is 69.09% and for 65 Cu is 30.91%. Since 63 Cu has the highest peak compared to the 65 Cu, so 63 Cu is more abundant compared to 65 Cu. How to calculate the average atomic mass from mass spectrum? The formula for average atomic mass, summation Qi-Mi divided by summation Qi, where your Q equal to relative abundance or percentage abundance of an isotope of the elements, and the M indicate the isotopic mass of the elements. The unit of the average atomic mass is AMU or atomic mass unit. Relative atomic mass. What is relative atomic mass? Relative atomic mass can define as a mass of one atom of an element compared to 1/12 mass of one atom of carbon 12 with the mass of 12.000. The formula for relative atomic mass equal to average atomic mass of element divided by 1/12 times mass of one atom of carbon 12. Exercise. Calculate the relative atomic mass of magnesium based on the given mass spectrum of magnesium. In order to calculate the relative atomic mass, we need to get the average atomic mass from the given mass spectrum. So first, we write the formula for the average atomic mass. Average atomic mass equal to summation QI/Mi divided by summation Qi. Q represent the relative abundance. M represent the mass. So based on the mass spectrum, we can interpret that for 24 mg, 24 is the M. 63 is the Q for the 24 mg. For 25 mg, 25 is the M. 8.1 is the Q for the 25 mg. And for 26 mg, we have 26 as the M and its relative abundance Q equal to 9.1. So we can substitute the value. 63 times 24 plus 8.1 times 25 plus 9.1 times 26 divided by summation Qi, where your Qi equal to 63 plus 8.1 plus 9.1. By using the calculator, you get the final answer for this part equal to 24.42 AMU. Now we try to convert the average atomic mass to the relative atomic mass by divided by the 1/12 of the carbon 12. So we have 24.42 AMU divided by 1/12 times the mass of one atom carbon 12, that is 12.00 AMU. The unit of AMU can be cancelled off. So we get the final answer is 24.42 without any unit.